Hey guys, it's Kim here, and welcome back to another crafting stream with Becky. Say hello, Becky. Hey, I did it right in one go. I pointed the right way.
Hello.
Today we are doing a second part of a several-part stream on repainting a cosplay gun. So a gun, making it kind of like, I guess, high fantasy, cyberpunky, futuristic. Cool gun, and as with all cool futuristic guns that you would find in the likes of Overwatch, Borderlands, Apex, Destiny, maybe, all games I don't play, Cyberpunk 20 whatever the hell it is, 77, they need some lights, because all cool future stuff has lights.
Everything has lights.
Yeah.
Stuff glows in the future. Like, the future's very glowy.
Yeah, so obviously you can use today's techniques with whatever the hell you want. But if you specifically were looking for making a fantasy cosplay weapon, do check out the first part of our repaint tutorial. Links are in chat. Below in chat? In the
Links are about.
in the video description below. But Becky, why don't you give us a quick, brief process thing of what you've done up to this point, and then what we are going to be doing today in the next hour or so.
Okay. So, last week, we cut up a Nerf gun.
Woo!
It was fun. So, this is still in pieces, as you can see there. This is still in the process of being repainted. Like, I'm not happy with the finish yet. This gold is not good enough. This, I really want to get textured, so I'm probably going to put something, maybe some leather on that, just to give it a nice grip feel. And I'm going to actually finish this with some bits to be really shiny and some bits to be matte, so just to give some distinction in the blacks. This bit, we molded. This was, have I got the original plastic bits? No, I've put them somewhere. Plastic. These bits did have a bottom bit that was ridged. Ridged bottom.
A ridgy bottom.
Ridgy bottom. Yeah, and I molded a bit of transparent warbler over that.
That's the transparent
and then
bit.
that's the transparent bit. And then painted it gold and masked off these bits so that when it goes on like that, we will be able to put red lights in there and have a light actually load through that before coming out of the gun.
Yeah.
So that's been really exciting.
Okay.
So yeah, repaint to one side, basically. We're going to put our gun off here. That's still in process. And mainly today, we're going to focus on electronics, wiring and coding lights to make stuff happen.
Okay.
So it's going to be quite a technical one,
Okay.
but hopefully it will be really helpful and people will get a lot from it. And I'm just going to do the basics. If you want to get into coding and lights and excessive things, Arduino has loads of tutorials online. All sorts of people have loads of tutorials online. So, or reach out and talk to me. But doing like full coding in a stream of this length, we could have like a whole day just on the basics of coding.
Good lord.
So
what is this array of things that you have on the table in front of you, and where can you get it? Is it expensive? Am I spending lots of money on this? I remember the days when we were doing lockdown crafts out of egg cartons and things you could find in your recycling box, and now we've moved on to Warbler, rotary tools, and now friggin' like a little electronics kit. Like, what the hell, man?
This is what I have here is an Elegoo basic starter kit. Elegoo do really good like boxes of everything you will need to get started with like coding and making basic stuff happen, like switches, lights. Some of their kits have motors and stuff like that. This one was 15 quid.
Okay.
So this is like a pretty cheap get you started, like get going. So like you can get ones that are up to like 100 and something quid and contain loads of different things and a bunch of different like chips and brains and things and lots of components. But a basic one to get you started is not expensive. So that's the kit I'm going to be using. I'll try and show this off.
And I'm guessing
I
you can
can
get
open
this from all pretty much everywhere online, everywhere.
Yeah, like Amazon, any electronics store. Like we have a big one in Bristol that's actually UK wide that's called RS Components. They do a lot of really good electronics. Like they're great if you want to order really specific components. I've ordered a bunch from them, but like don't know if that's properly visible, but this is everything that kind of comes in this kit. So lots of, it's not really in focus, but lots of useful stuff basically.
Yeah, okay. Now, not specifically me, because I did do a whole module in this at university and I have my own soldering kit and I have built a few little audio units, but hey Becky, I know nothing about electronics and I am dumb and I like licking batteries. What do I need to know to do electronics? Because this is really intimidating, but I also like shiny lights because I'm basically a magpie. Help.
I mean, for a starter, this is just if you want to code your lights to do snazzy things. Like, if you watched the book tutorial, annoyingly, the last one I had is now glued into the book, so I can't show it off.
The lily pad light.
Like, the lily pad light we used with that, which was like literally just a little battery holder with plus and negative like out points and an on switch. If you just want to have your object, your cosplay craft light up, just do that. Like literally just. Or even you can buy lights that come preloaded with battery packs, like the one we used in the TARDIS tutorial. Like, you don't need to do any of your own wiring or coding if you want to have lights. It's only if you want to get fancy.
Okay.
But it is, you know, it's interesting to try.
What kind of things would I need to Google if I was just looking for, like, a neon... Like, if... So I want a futuristic gun. If I just want a neon light in this, like a cool... neon pink light, what would I Google, like, if I didn't want to do coding? Is it literally just like neon light?
Pink LED, like most little lights that are going to fit in things are LEDs. Like look for LEDs with battery pack, LED with switch, like stuff like that. And you'll often find things with like small switch packs that can just be run with a coin cell battery and are really easy to then small to fit into things.
Okay.
Like you can get fairy lights that run on like little batteries. Those will work absolutely fine. But yeah, it's like you don't need to do this.
Okay. But also, kids, don't lick batteries. Don't
lick batteries. Like don't lick any of this. And you'll notice today I've got a water bottle back, like, and I haven't got a cup of tea. No open liquids near the electronics.
Okay. Don't dribble on it.
Don't throw water on it. I mean, it's like, so we're gonna start. This is an Elegoo Uno. So this is a circuit board. This is a coding board. So it's got a USB input so that you can load the code onto it. This is the chipset. This is the brain. And these are all your outputs, inputs, things that you're going to plug in. Now, this is a breadboard.
Doesn't look like it's made of bread, though.
It's not made of bread.
Well, that's disappointing.
I know. I don't know why it's called a breadboard. If anyone does know, please weigh in. So a breadboard is basically a testing zone for you to wire your electronics without having soldered them so that you can check everything works before you connect it up.
So apparently from 7th Chevron Locked, Google says the term breadboard comes from the early days of electronics where people... would use bread as testing... No, sorry. When people would literally drive nails or screws into wooden boards on which they cut bread in order to connect their circuits. So you use a cutting board, a wooden cutting board that you traditionally cut bread on, and they use that instead. So now that's why we have breadboards. So thank you. Today we learnt. Carry on.
When wiring things up, just a little bit of where we're going at the end. Like, if you want to reuse your circuit board... You wouldn't solder into the circuit board. You'd use your wires, like these. Let's take these wires apart. So these wires are male to female, female to male. Sorry, does it matter? Male to female, female to male? I don't know. They're one end of each. You would use these to connect your soldered circuits and your soldered wires into your little board, and then you could take it out. That's if you want to reuse this. If you don't, if you want to permanently put something inside your gun, you need kind of a custom circuit board. So this is a custom circuit board that was 3D printed for a project I was on.
Oh.
It has its own little brain there. It has lights. It has all the resistors coded in and nicely soldered, nice and small, battery switch all included. And this has been coded to do this. This was my first ever Arduino project, so I've progressed a bit. But yeah, so there are companies that will custom print boards for you, or you can buy like simpler boards where you just kind of fit the brain into and it's got the connections. This is basically a development board, so it's the board for while you're working things out and loading the code on.
Okay.
Like when doing this one, this chip had to be taken out and put into like a tiny USB board to upload the code onto it, and then put back into this to check if it was working. So this didn't have a proper development board. This was kind of it was a very boring step-by-step process. But the custom print thing is very useful. Right. So this also has a power input so that you can connect it up to main power, or you can get a little battery adapters that will connect to this and power it inside a prop or something. So you can power off this without having it running off mains power. You just need the suitable adapters, or you want something that has its own battery pack contained. Right, first things first. But yeah, if you can see, there are red lines and blue lines on either side of the breadboard. The blue lines are the negative, the red lines are the positive. So minus is where your grounding goes, positive is where your power and your input goes. That make sense to everyone? So the first thing to do is there is a ground connector on your board, and there is connect that up to the negative on the breadboard. Woohoo! That's exciting, wasn't it? We're really pushing the boat out today. But the ground is the most important. Like, that stops anything short-circuiting. It stops any electric shocks. Like, you must have the ground in place. Always connect that first. Always disconnect that last. Like, right now, this is not powered. Like, this will not be powered until you plug it into a computer or into a mains power. But it's just good practice to get into that your ground is your first wire and last wire out. First wire in, last wire out. Just because then if that's your habit, you won't mess it up when something is live. So there are numbers up the side here, and it says digital output. I really feel like I should have zoomed in my camera. In most starter kits, and if you buy LEDs, they will come like this. If you buy, they will come like this. I'm gonna try and make this as clear as possible. Not pre-wired with a resistor. If you buy LEDs with wires, they will usually have a resistor built in within the wires. But wiring like this from scratch, all lights need their own resistor. Resistors come in kits. They will come with different power levels depending on like how you're powering things. Also, they have a wrong and a right way round, just like lights. They have a negative and a positive. In this case, it's slightly different with all resistors, but on most cases there is a darker ring around the resistor. This is very close. There is a darker ring around the resistor on the side that is positive, and the lighter rings trail off towards the negative side. Positive and negative are very important. If you get them the wrong way round, your circuit won't work. It won't explode, it just won't work. Okay. So at least it won't explode. With LEDs, the longer leg is your positive. The shorter leg is negative. So yes, that's all of them need to be wired up like that. So we're going to start with 5. I've got 5 red LEDs. So we're going to just all this middle bit in your breadboard that doesn't have a red or blue, a positive or a negative, is basically space to put all your components. So we're going to put all our lights in there with positive to this side and negative to that side, so that when we're wiring up, we know how to connect them. And I'm just going to leave a little space between them all, because otherwise it gets very fiddly.
Yeah, fair enough.
Right, so on a circuit board, like on a board like this, 0 and 1 on the numbers of digital output are slightly different and can be used to code fancy things. They have other letters next to them so that you know that. So just ignore them when doing lights and go straight for 2. So you want to ignore 1 and we want to go into 2. And this is your positive. So basically power's coming through here and going through the positive wire. So this needs to connect to it needs to be in line with the positive leg of the light. So this is the great thing about breadboards, that you just line things up. Like, you don't need things to be perfect and exact at this point. You're just lining stuff up. Your resistor then goes from the negative on the light back to the grounding wire. So it needs to line up with the negative leg of the light and then go into the minus row so that it sends the power back to ground. See, I told you it was a technical one.
I just like this because I said that resistors swing both ways. We've now got stuff in chat about bisexual resistors. And Purple Mandrake says, y'all been sleeping on the true bisexual icon, resistors.
I feel like we need like a resistor pride shirt or something now.
Resistor pride. And then the bands on it are the bisexual colours.
Yes! Oh my god, someone make that happen, please. Like see that in the craft Discord over the next week.
Oh, God.
Oh, that, yes, please make that happen. So yeah, I'm just doing exactly the same thing with all of these, just connecting the positive leg of the LED to an digital output on the board, and just connecting the resistor to the negative leg of the LED and then back into the grounding wire.
Okay.
So it's going to be the same with all of these. Just going to connect them up, and I'm just connecting these in sequence. So 2, 3, 4, 5, 6. But you can connect them to any numbers, and it depends like whether you need like sometimes you might want a bit of space. Just it might make your coding easier if the numbers are a bit separate and you're trying to make them do different things. It just depends what kind of setup you're doing.
Mm-hmm.
So there's our circuit.
Okay.
So that should now. I'm now going to deconstruct my extra layer here.
Behind the magic.
Behind the magic. Because now you guys get to see my laptop.
Oh god.
There. Here we go. This is what I wanted my lights to do. So the idea is that these 4 will be our loading along the bottom, and this one is going to be the shot. So the shot stays on its own after the kind of charge has loaded. Yeah, I mean, also what would need to happen with this is I would code in a button that will be added to the trigger. But today I'm just coding the lights because there's too much.
If you're watching this on YouTube, we've just done a little screen share of Becky's screen. So she is here, but I can't bring a camera in at the same time. So this is basically what it looks like. This is what the coding looks like. So Becky, why don't you explain what the hell I'm looking at, and what is this program? What is it? What are we doing here?
So this is the Arduino coding software. So Arduino is free to download. This software is free. I keep gesturing with my hands and then realizing no one could see that. So yeah, this software is free. You can download it, and just, this will work with a lot of like off-brand chips that are not officially Arduino. Like, don't feel like you need to spend the money on a full Arduino. Like Elegoo works. Like the one I've got on my little circuit board is an AT Tiny, which is really good for like small little wearable tech things. So yeah, your board, in your tools, you'll want to include your board, which in this case is the Elegoo. It's an Uno R3, so this is Arduino Uno. But this just has the list of the kind of boards you're using, or you could be using. That's your circuit. So that's just your little brain of which brain you're using. Bigger ones will give you more power, more possibility to do things. Smaller ones, not so much. Like the AT Tiny on this little board is only really capable of like powering LEDs.
Okay.
It's not capable of like feeding loads of inputs and things. So you get that correct. There is loads on the Arduino website. There is loads of free resources of things like finding the code for what you want to do and how to customize it, and like what things mean. So yeah, there's loads of resources for this. Don't feel like you're going in blind. Go and read some of the Arduino things. Like literally, if you Google Arduino making lights flash or Arduino turning lights on, like it will tell you how to do it. So don't get overwhelmed by this at all. This is a lot simpler than it looks. So here at the top, we have our LEDs listed. These are the pin numbers, so 2, 3, 4, 5, 6, 7. These are the pins that we put those on our digital output on our board. So we were using pins 2, 3, 4, 5, 6, 7, and we're giving them names that we will use within our code. So LED 1, LED 2. Do
those automatically come into the program itself, or do you have to put that in?
You have to put that in. So all you will see when you enter, if I go file, new, right, this is a new setup. This is what Arduino looks like when you open it.
Did something change there?
Did that not? Oh, it's because I'm only streaming like the one thing.
Yeah.
Anyway. Okay, yeah. So what you will see is this line, which says void setup.
Okay.
And at the bottom it will say, and it will also show you the void loop, which is here. That is all you will see when you open a new Arduino coding page.
Okay.
So all of this, because it massively depends on what you're putting in. Like you might not have any LEDs, you might have a buzzer, you might have inputs instead of outputs. Like you might have it telling you how much light is on the thing. You might have light dependent resistors, etc., etc. So you have to put everything in because you have to define it all.
Okay.
So these are just telling us where our LEDs are going and telling the coding, like what this is our name, LED 1, it's going to pin 2. You could call it like green LED if you're using multiple colors and you want to define it.
Yeah.
That can be any name. You're just telling it like that's going to pin 2. That input is pin 2. Your void setup literally just tells what that LED, what that pin is taking, what that pin is doing. So in this case, it's a pin, it's an output.
Okay.
Because we are sending a signal to make something happen on that pin. We're not receiving. So if you had a light dependent resistor, which would react to how much light there was, it would be an input. You're literally going, we want this code to tell something to happen. So that's an output. If you want that thing to tell the code something, it's an input. This is just defining that all of these are outputs. So that's your setup.
Okay.
See, I know it looks complicated, but it's quite simple in a way once you get your head around it.
So I've got two things. One thing, Lord Wolfie in chat says there's also pre-made sketches in the programming app itself.
There are. Where are they? I couldn't find them when I was looking at it.
Okay. So there's that. Also, what if I am a big dumbass and I've never coded anything in my goddamn life? I guess you would recommend going to the original Arduino tutorials, or like, is there code like somewhere where I can just look at coder examples and stuff like that? Because coding to me is a black art, and I don't understand it.
There are loads. Also, like, code is one of those things people are really, it's a really collaborative thing. Like, people are really happy to share their code. And really, like, people will write something and go, they'll also provide a circuit diagram so you know how to connect everything up on your breadboard.
Okay.
You can go online and literally Google, like, I coded a light dependent resistor and I didn't know how to do that, and I just Googled light dependent resistor to turn on LED, and someone went, I'm sharing my code, let me know if you use it. It was like, okay, so we
got a couple of comments on that. First of all, thank you to YouMemeG and Lord Wolfie, who says if you go to File and then Examples, that's where you can find presets. And then the Big Friendly Viking, says Google is the coder's best friend. And Kiichi Shimikaze says YouTube has infinite coding tutorials for every language imaginable. Kiichi Shimikaze also says, is this like simplified C++?
Yeah, it is a bit. And like, I used to code websites in C++ a long time ago.
Yeah. Okay.
But yeah, if you have a basic understanding, you'll probably get on with this fine.
Yeah. Okay. And YouMemeG says, I swear whenever I do something with Arduino, I copy and paste and change about 3 lines. So if you are a bit intimidated by this, if you are looking at this and being like, oh God, what? There are resources out there that you can literally, as YouMemeG says, copy, paste, and then just tinker with it to suit your build. So don't be put off by it.
I've just opened up their file examples here. So there's like display, strings, USB. There's a bunch of things that basically will create the examples, like blink, basics, blink makes an LED blink. And that will just put in all the code for you. So right, your void loop is where you tell your Arduino what to do. It's where you actually tell it what you want this output on these things to be.
Mm-hmm. So specific to this project that you are working on right now, what have you added in? Like, what instructions have you added in? I'm guessing, I'm looking at it, I'm guessing you've kind of added the sequence in, which is the wait for 200 milliseconds.
Yeah.
And then the last one is wait for 500 milliseconds, which I'm guessing is the amount of time that the light comes on for.
Mm-hmm.
Okay.
So everything that's after these 2 backslashes is not code. That's ignored by the coding.
Okay.
So those are notes. Basically, it's really useful to get into the habit of writing code this way with notes, because when you've got a huge thing of code and something's not working, going through your notes and finding what each thing is meant to be doing. Because if you were just looking at like these lines, you might not know what that's meaning. And a lot of code that you find online will have proper notation because it's, new coders can use it. And so it's telling you what this is telling the program to do. So this is turning on LED 1. Digital write means it's making it do something. It's making something happen. So it's a digital writing of that. It's like write. If you're writing something, you make it happen. It's a digital output. So you can also have analog outputs. And this LED high is basically on, and low turns something off.
Okay.
So write, LED, on, essentially is what that's.
Yeah. So Treffley says, so the bits that are after the backslashes, so turn on LED 1, is that like naming layers in art?
Yes, absolutely. But yeah, you can put as much as you want to on there. So you could literally say, turn on LED 1, which is the purple LED, which lights up so-and-so's face. So
like comments as well? Like
comments, descriptions, stuff that makes sense to you, like whatever you need to put in there, as long as it's after 2 backslashes, the coding program won't look at it.
Okay.
So yeah, digital write is telling it to make something happen. LED 1, which is our coming to pin 2, so it knows that from up here, and high is turning it on.
Okay. I like this from Lord Wolfie. As my lecturer said, coding isn't just making it readable for the computer, but for anyone else working on it, making it readable for anyone else working on it. And I think that's something that definitely I found in my life as a technical engineer. So as a video editor, as a sound engineer, as a camera operator, as a streamer as well. One thing that's always been drilled into me that I'm really thankful to my university for is make your projects clear, make them like usable, make them so that if someone else opens it and has to look at it, they can be like, okay, I see what the project flow is, I see where things are going. Like, I think it's just a really good habit to get into, is to be neat and label your projects. For example, this weekend I had to run the High Rollers show, so I was running vMix behind the scenes, which is a very powerful bit of software that basically acts as a live video and audio mixing software, basically. And one of the reasons why I was able to run it so well is because Chris Trott, the lovable twerp Chris Trott, his project that he's been working on for months now, ever since lockdown, and we've had to use vMix, was so clear and wonderfully labeled, and all the assets were properly labeled up in different folders, so all the root paths made sense. Like, I was able to be like, okay, I can reverse engineer, I can see his thought process, I can see where things are going, and I think it's just generally good practice to have, whatever your technical sphere is. Even if you're not necessarily handing the project over to someone else, like, it's just a good space to get into.
Alaneth, they're saying, and future you is essentially a different person. And I think that's it. You might think this is not important because you're only working by yourself. But if you've coded something and suddenly, like, a year later you come back to it, your brain may just space out and look at it and go, what the hell was that? Especially if you're quite new to coding, if you're not comfortable with it. Like, you don't want to have to relearn everything every time. If you've got good notation there, you'll just know what it all does. And you can work backwards, that reverse engineering. And having that good notation actually allows you to expand your coding knowledge a lot better, because you're like, okay, well, that bit's doing that, so I know to take that bit out, or I know to add that bit into something else. So yeah, we've got our LED, just digital write LED high is just telling it to turn on. Then a delay 100, which wait for 200 milliseconds. I don't know quite how they've got those numbers of 100 and 200 milliseconds, but that was in the code I copied.
Okay.
Again, just digital write LED high, that's doing the same. So all of these are just doing the same thing, and they are literally just turning on all those lights. So that's just turning on like 1, 2, 3, 4, 5. Turn on our 5 lights. Then I've got a longer delay of 250 before the lights start going off. So then you want to go digital write, telling something to happen, LED 1 low, which turns off LED 1. I want all of these lights 1, 2, 3, 4 to happen at the same time, so there's no delays written into that. So I just moved something. The undo key is your friend as well. That is if I can impart anything, the undo key, which is Control Z or Apple Z on Macs, and it is just, it will save, like, anytime you do something, just undo and save stuff. But yeah, all of these, basically, if you haven't written in a delay, things will happen simultaneously. So although it seems like, because it's line by line, you'd think like it happens sequentially, that happens. So, I mean, it will read it sequentially, but it happens so quickly that it's the same. So that's happening simultaneously. So no delays there, so they all turn off. I've got another delay. So all that this delay is doing is basically waiting and holding the LED 5 on. So LED 5 has been turned on earlier by this piece of code. We haven't told it to turn off yet. So that delay is just delaying LED 5 turning off.
Okay.
This line is actually duplicate code. I didn't mean to have that in there. It was just, adding another delay. This has a delay of, because this is a loop, this has a delay of 100 before it starts the loop again.
Okay.
I will add into this at a later date a button, so it will be it won't be a loop, it will be a button trigger.
Because you're going to get it triggered on the physical trigger on the gun, right?
Yes. So I want this to basically be what happens when you shoot. But I don't have the button I need for that yet. So I didn't want to code that in and be like, don't do anything. But yeah, so this is basically, because this is a loop, this is just saying there's a delay and then it happens again. And it just keeps happening for eternity while this is powered. But what we will have is it's powered via the button. So it will be when the button, there'll be a line here that basically says when button is pressed, this happens.
Okay.
And then stops until button is pressed again. This board, some boards you can just overwrite with the same name of sketch. So a piece of coding in Arduino is called a sketch. That's B1. So I will save this now as I've basically called sketch gun 4. Yeah, this board does not want to overwrite. It requires a new name. But yeah, you can go through and delete your previous ones that weren't working once you've got what you want.
I just always love it though in tech access, just like, your project version is just like project V1, V2, final V1, final V2, final V3. Like, I just spoken like a true technical editor.
And then you have like final, definitely final.
Super final, mega final, absolute final, definitely
final,
the final.
Final V1, final V3.
V1.2. Yeah, I feel that.
Yeah. So yeah, there's a great tool in Arduino that once you've written everything, there is this verify compile option, which can also be accessed via this tick here. That basically will go through and compile your sketch and into code. And then at the bottom, you'll see it says done compiling. And it comes up with this little thing like telling you how much space it used, which will make sure it fits on your brain, your chip. Sorry. But if that's wrong, if the code is wrong, so actually I can make this code wrong. So you'll get this little orange warning and it will highlight what's wrong.
Right.
Which is great when you're a first-time coder because it will highlight the stuff that's not making sense. It won't highlight like if it's not working, if you know, like you've written like right over here and you haven't told it to turn off or something. It won't tell you if the actual instructions are correct, are going to do what you want them to do, but it will tell them if there is something that is messing up your code.
Okay.
So it's really useful, like, you know, like that, like putting a double bracket, like stuff that you might accidentally type.
Just like a little typo, yeah.
Or if you haven't defined your inputs or your outputs properly and it's like you've got this LED but it's not actually pointing anywhere, it will tell you stuff like that. So that's really useful. And then you can just remove it and click yes again and it will compile it again and tell you, yes, it's correct.
That works. Now. Okay.
Yeah. And then and then you just plug in your board. And you can either go sketch upload up here, or you can just click this little arrow here.
So that has uploaded this little bit of coding into the electronics that the hardware that you have.
Yes. So that's you connect your circuit board via your USB and upload that, and then that will, you know, put that onto your board and make that happen. So I'm not gonna, you know, fix this in the gun, but I'm just going to kind of show you how this will look in the end. So now that that's all working, you would take the lights off the LED, connect them all up, so you'd use actual
lights off the LED or lights off the breadboard?
Lights off the breadboard. You take the lights off the breadboard, keeping them in this kind of configuration, and connect them using wire, like just standard wire, not cables like these. And then you'd solder them in. Now, the best thing to do is connect everything up, your wires all twisted together, connect your circuit twisted, then test it again, then solder it.
Okay.
Like, make sure that you've transferred off the breadboard into your circuit correctly, because there is, like, as someone said, it was working last night. Like, there is so much room for error here. It's very easy to go, oh, it worked on the breadboard, why doesn't it work now? And it's like you've missed out a resistor, or you've connected one wire to the wrong end of the light or something. Just test it before you solder it, because once you've soldered it, I mean, you can get rid of solder, but it's a mess.
It's hard.
It's not like you'll ruin your lights. You'll ruin all your connections. You'll basically have to use new lights and new things, and it's blah.
Yeah.
So test. So we take this apart, but what I want to show you is this is essentially roughly how this will look in the gun, because I'm not going to solder it today because there's still a bit of, like, you know, I was saying I want to add in a switch.
Yeah.
And code some things. So
are we gonna do like another stream where you're soldering, or are you gonna do that off?
I don't know.
I think in terms of time, we might need to. Yeah. We'll have a conversation about that later.
That might not be on stream, just because that's one of those very slow technical. Making. Like, and maybe at another point we'll have like a soldering sessions. Yeah. So what I'm trying to do actually is so this is a circuit board, a mini circuit board that was 3D printed at my makerspace. Part of why I want to chat to them today is to try and get them to make me one of these to fit in the gun. Because I'd need more LED outputs, and I'd need a different switch type. But actually, that switch was soldered on. It's just got 3 connectors. And so,
and then you're gonna have a lily pad battery. As well,
this has a battery. This is a battery. This thing.
Yeah, that's what I'm saying. Yeah.
Yeah. So this wouldn't need a separate lily pad. This is the whole thing.
Okay.
But yeah, we could then wire these LEDs on wires rather than soldered into the thing. So you'd solder a wire to this. So I'm trying to get my makerspace to do me a custom one to go in the in there, as it were. I just want to demonstrate roughly how it will look in the gun when we're finished, because we're not going to get to kind of fix it all up today.
Yeah.
And kind of just a mini, you know, kind of, I want to kind of space these out a bit more, I think. So what I've done is I've just used those female to male extension cables to kind of feed my LED into the gun. So this is another way. Like, I don't have loads of these. I need to get some more of these.
So they're just extenders.
They're just extenders. So you take those out where the LED would be and like run them into your thing, and it just sort of gives you that space of, if you want to kind of see how your LEDs will look in situ, you can do that still on the breadboard. Like, you don't need to kind of expand. But I'm just going to space these out so that I can see them kind of flashing in this, and we can show off kind of how the whole thing will look.
Okay. Ace of Thorns says, do you absolutely need to solder stuff?
No. Soldering will provide a solid, more reliable connection. A lot of like what I do with my lily pads, really solder my lily pads, I just twist them, connections. There's also, if anyone's seen, you can get heat shrink connectors, which are like little pieces of rubber that you put over the join, and then you apply a bit of heat to it, and it shrinks and holds the join. Now, if you're really like building a circuit, then you want to solder it and then put heat shrink on it, to really like solidify it. It really depends if you want to reuse stuff. But I mean, like, wires and LEDs are not expensive. Like, you can buy a pack of LEDs of like 100 LEDs for a couple of quid. Same with wires. So like, don't hesitate on like using those. And like I said, like, wire up your circuit and then use some of these to connect it to your actual circuit board if you want to reuse your circuit board. So yeah, electrical tape, again, another, you know, useful way of connecting stuff.
Yeah. We got a couple of tips as well. Meme G says Wago lever connectors are also good for people who don't like soldering.
That's how
so
that's
cool.
gonna look. And then this one has unfortunately stopped working, which is good.
Standard.
Classic coding, but like this will light up, charge up, and then the light will come out of the front of the gun. Is the end goal.
The end goal is pull the trigger, those lights go off, and then the end light goes off in the chamber, barrel, shaft, hole, gun hole. So that's your tutorial. That is your basic guide to LED coding and crafts. Any final thoughts?
Don't be scared by coding. Like, go give it a try, see what happens. If you've got questions, reach out to the community. They are wonderful. And don't look at things like this on YouTube or, you know, on props makers and say, oh, I wish I could do that, because you really can. Like, it's doable. This is not complicated. And you can do things like, even if you don't want to try coding, like, go and look at lights like we used in the TARDIS. That's a breathing light. You can get a breathing light and put that in your project, and that will just give it that kind of glow. Like, there's a lot of lights pre-coded or pre-soldered, come with switches that you can get that can just elevate stuff.
Bye.
Bye.
Bye.